So now JL will walk you up. I must say it was a lot of fun to listen to the presentation. It was definitely engaging and very interesting to think about things that we believe to be true, but from a different perspective. I think for some of you, formal may be the same thing. I don't know how many of you are familiar with formal or with Jasper. So my agenda in the 20 minutes that I have is to try to cram in several topics. I'd like to introduce Jasper to you. I really don't have enough time to introduce all of our technology, so I chose a very specific business perspective to introduce Jasper to you. I want to tell you why Jasper is so successful through the visibility of our strategy and our choices that we've made in our strategy. Then I'll transition to talking about one specific challenge that actually, interestingly enough, nobody has mentioned today, and that is security verification. I have to admit I'm very, very surprised, on one hand, not to have heard a word about security today. On the other hand, all the 7 customers that we have that do engage with security, none of them is willing to come public and talk about it. So, you know, maybe that's part of the syndrome here. Security is a very sensitive topic for many, many people. And last, I want to say what I think it means to you, how the expansion of formal is going to impact your life as a verification engineer or as a designer in general. If you look at Jasper through the glasses of the business measurement, Jasper today is the most successful and best private EDA company available in terms of size, in terms of growth, in terms of profitability, and in terms of its technology. I know that it's very comfortable to put percentages on the slide because then you don't have to talk about numbers. Percentages are just ratios. But I will give you one base number. Jasper's revenue is in excess of $25 million US per year. The company has been growing tremendously fast in the last 7 years. The company has been profitable for 3.5 years. We are about 130 people worldwide, 4 development sites, 1 in Brazil, 1 in Sweden, 1 in the US, and 1 in Israel. We are, as I said, by all business measurement, the best EDA, private EDA company today in the market. I want to take even a closer look at the business measurement. You can see that if we look at since 2010, our compound annual growth rate, I'm assuming everybody here is an engineer and know how to compute it, is about 37%. 37% compound annual growth means that we're doubling every 2.5 years, maybe 2 3/4. On the other hand, the number of licenses that are installed at our users, unique licenses, is more than doubling every year. So what is the meaning of that? How can the revenue grow so slowly, but the licenses go so quickly? I think the reason for that is because there aren't enough PhDs. And because of that, Jasper had to implement a methodology and tools that allow leverage at the customer site. And today, our customers are using parallelism, both in the macro and in the micro level on a broad scale. These represent essentially thousands and tens of thousands of licenses of formal deployed. Another measurement is that you can see that the number of customers, unique customers, logos that we have is growing relatively slowly. I'll share with you another piece of information. Worldwide, we have just 25 customers. That's it. On the other hand, our revenue is growing very fast. What does that mean? It means that our strategy, our business strategy, has been to work on wide deployment at major accounts. Rather than chasing 50, 100, 150, 300 customers for $25,000 each account. Our focus is to make sure that the big accounts that engage with us are successful and proliferate and grow every year. In order for revenue to grow faster than the number of customers, the existing customers have to grow their business with us tremendously every year. And the last measurement I want to show you is that the number of users is growing on average by 80% every year. Users meaning individuals that are registered on our Formal Expert, which is the support website. And then the number of licenses, as you saw, is growing faster than that. That means that our users are able to use multiple licenses in regression, in parallelism. So where is all this success coming from? How is Jasper able to take Formal, which many have tried in the past, to make a success, a commercial success? Why is Jasper a success and other people are not? I think the difference is in our strategy. Very early on, Jasper decided that they're not going to accept the limitation that were the conventional wisdom in Formal. Today and before, and as early as 2005, 2007, Jasper decided that we are going to expand the reach of Formal to fit the size of the problem. Where other people accepted that Formal needs to be complicated, small, and difficult, Jasper worked to create higher capacity, higher performance, better proof convergence, more automation, and more usability in terms of debugging. I think this strategy is paying off for us today, where Jasper is able to be used in designs that are in excess of 100 million gates, with achieving proof convergence, parallelism, and automatic property generation. Before I dive into talking about one specific solution, I just want to share with you our product architecture. Our view is that Formal cannot be used as a single application. Traditionally, Formal have been viewed as you write a property, you prove it, and you're done. But that's one, very, very limiting and also very difficult to scale. Our view is that the much better approach to Formal is to try to look at Formal through the lens of the verification problem. So today we are deploying a wide array of different apps. Some of them are relatively simple, like connectivity, expropagation, control and status registers. Other applications are much more complicated, like deadlock detection or architectural modeling app that is helping ARM to verify the coherency of AMBA and other types of protocols like that. Other applications are low power verification, coverage design verification, and so forth. Today, what I want to talk about in the remaining time that I have is about an application for security path verification. I'll try to introduce what that means and what it is. Why do you need security, and why is security important in the hardware? Because if the hardware is not secure, nothing is secure. You can design secure applications or the operating system, but if the hardware, the fundamental hardware, is not secure, you're not going to be safe that your key or encryption key or whatever secure data that you need is going to be secure in the final product. Maybe this goes without saying, but conventional methodology is just not applicable. Simulation is one, too slow, too inaccurate. If you write a directed test to verify the security of a particular hardware, it's going to require that you be the hacker, that you understand how hackers or bad people think in order to violate your own hardware. I don't think that's a very successful methodology. Other Formal solutions simply do not have the unique and patented technology that Jasper has in path synthesization. This is a example of a typical SOC. This is taken directly from the ARM website, nothing proprietary about it. By the way, no implication here whether ARM does or does not use this particular system. The red areas are some of the secure zones. These are areas that specifically are guaranteed to be safe and secure, and you can store data there without fear of leakage or contamination. So the security path verification has some basically 4 important features in it that are important to highlight. One, it automatically generates the properties that are required for the verification. So as a user, you do not have to know how to write the specific properties. You do have to understand your security requirements and be able to at least list them in a table, Excel or whatever other format that you're using. The other important thing is that the application is then going to verify the absence of data leakage. It is going to verify data sanctity, and I'll define what that means. And finally, it's going to take care of fault tolerance for security. So what does data leakage mean? If this is the secure area, and if the data is going to be written from the approved path into the secure area, a leakage, any leakage, means that the secure data may end up at a particular port or a path or a data node which is just not allowed to. So how do you know if this is going to happen or not? So the methodology that was created is to extract from the specification all of the particular path, create the particular properties that define the relationship of one source and many destinations, where this would be the source and there would be many destinations. Some of them are legal, some of them are not legal. How do you know? It's in the stack. What does the tool do for you? The tool then shows you where can the data reach. It is your job to then understand whether these particular counterexamples are legal or not legal. But the tool can exhaustively and comprehensively tell you for all the existing paths in the design if the data, secure data, can reach there, leaked or not. It's your job then your job to decide how to fix it or if any fix is even required. So one other way, once you decided that something has gone wrong, is that you need to debug it. The tool is providing you then a graphical user interface with a waveform that can show you the temporal relationship between where things started and where they ended up. And you could decide, okay, I understand the condition now that has led to this particular potential leak, and I can fix the leak. Data sanctity is the opposite. If you have a particular secure location, one of the questions that you're asking yourself is, who can overwrite this particular location? Not if it can leak, but who can say not chastised anymore. And the methodology is very simple. You start with a specification, but this time there's many sources, but one destination. And there's a special form of assertion. It's generated for all the available paths automatically. You don't need to do it. And then you just repeat the process of proof and counterexamples. The counterexamples then can be debugged. You can understand where the particular sanctity condition exists. The last thing you can do is that if you're really thinking about security, you need to make sure that your design is also secure in the face of fault. And a fault can be, by the way, intentional or non-intentional. Intentional fault might be that somebody might ground something. They can disable a clock. They can disable an interface. You don't really know that. So here, what the tool does with the methodology is that it is inserting specific faults into different locations and trying to verify the sanctity and the leakage in the presence of these faults. This is probably more of a heuristic process and still needs more and more development because the number and the type of faults that you can insert is large. Let's put it that way. Skip that, but this is one of our customers. It's a gaming system, so they expect a lot of teenagers to try to break into it. That was really important to them, and they were able to find several sensitive storage security area. So what does it mean to you? You know, what we believe is that because of our strategy, because of our growth, because of our technology, because of the way that we deploy our tools, because of our customer base, because of the expansion, because of all these things, and because formal is exhaustive and comprehensive, in the future, the technology from Jasper is going to pervade more customers, larger problems, larger chips, and even more types of problems. 3 years ago, we had 2 products. Today, we have over 12. And when I say products, I mean these different application-specific solutions. We believe that users are going to drive the adoption of formal at the same rate that we have seen so far, and it's driven by their ROI. The only thing that drives all of our customers to grow the number of licenses, more than double every year, is the ROI. You know, it's interesting to look at Jasper. This is sort of anecdotal in comparison to Moore's Law. By the way, the original law was every 2 years. That's the original paper. Somebody changed it a little bit later to every 18 months. So that's a compound average annual growth rate of 42%. The capacity of Jasper tools in the last 10 years is doubling every year in terms of number of gates that the tool is able to handle. And I don't believe there's any other formal methodology tool on the market that can address the complete SOC of these sizes. We believe that in the future, formal will be your default tool. Simulation will be a very important methodology, but will no longer be your default. I don't know when this future will come, but it will. The tools will have the capability to address many types of problems, not just what you traditionally think of applicable to formal. This is a prediction from our president in the last Jasper users group. And I don't have a date on when it will be true, but I think it will be true. Thank you.
Thank you.